Hi everyone, welcome to this workshop on Docker. Hope you're familiar with our website. If you want to do labs with us or decide to do the labs in future from our website, you would need a registration from Docker Hub. So please make sure you register over there. It's fairly simple. You have to choose a ID, put an email address and a password there. The way we're going to operate this workshop will be we'll be doing the session over YouTube Live. Feel free to chat in your questions or any concerns you might have. And if you decide to do lab with us, we do have a Google Meet link as well. It's in the video description. You can join us and share your screen, and we can troubleshoot the issues you might face with the lab. As far as agenda goes, we will be using the Docker labs from our website. If you want to access them, you can go to our website, go to Docker labs. It'll show you list of labs we have. We will be adding more as the time passes in future. You can click on one of the picture and it'll take you to the lab, which we will be doing after the quick introduction to containers and Docker. With that, let's wait for a few minutes for others to join in and we can start. So what is container and what is Docker? Container essentially is a process with the isolation of a virtual machine, and Docker is a tool we use to manage it. But let's go deeper and understand why do we even need it. So in the past, we used to get a server, just like your own desktop or a computer, and we will install an operating system on it. On the top, we'll install an application, and users can access our applications and things goes from there. The overutilization of application resources or underutilization lead to the hypervisor or the virtualization technology. And in the virtual environment, what we do is we get the server as the infrastructure, install a hypervisor layer on it. Could be a Hyper-V, could be a ESXi, could be Zen. So we install an operating system which handles the hardware and gives us a virtual environment. In that virtual machine, we install an application and a guest operating system. So essentially, we were duplicating the kernel environment. So we have a kernel in the hypervisor, and we have another one in the guest operating system. And that's where the Docker comes in. Docker gives you the similar isolation of the virtual machine, but it doesn't require you to install another guest operating system on the top of it. So on a 1,000 level view, it'll be in a container is just a virtual machine without an operating system on it. So containers are very flexible. Any application could be converted into container and be containerized. They're very lightweight as most of the kernel parameters are taken out, and they are responsibility of the host operating system where the containers are running. They're portable as they could be moved to public cloud, private cloud from one machine to another very easily. So they're very self-sufficient and could be replaced and upgraded without disruption. You can easily scale them to one from thousands to back again to smaller level. So container apply aggressive container isolation and contains, sorry, they apply very aggressive constraints and isolation to processes without any configuration required on the part of the user. So they're very secure compared to the process we run on the on the guest operating system or on a virtual machine. They also solve the dev versus test environment, wherein in the past, the developers will have a dev environment. They will have their own libraries and their own dependencies. And when it goes to test, they will not be able to, they will not have exactly same environment. And the trouble will be that they'll not be able to get the same results. It could be as simple as using different version of Python, or it could be as complicated as a very minor version change in the dependent library. As developers and testers work in a different environment, there could be multiple teams doing development and sending it to the same testing team. There could be those challenges. Then there is the problem that developer always say that it works on my machine. I'm not able to replicate the issue. And the frustration comes from the tester that I cannot deliver your machine to the client. I have to deliver the production environment. So in the container, it's a very contained environment. All the binary and the libraries dependent on for that process, for that application are packaged together. That's why everybody gets the same environment. And there's no difference between dev, test, or prod. Essentially, how the Docker helps creating the containers is we create a Docker file, run a build. When we do the build, it creates a Docker image, and we use that image to run and create a container. Other components involved in the Docker is client, a Docker host, and a registry. So a client is your CLI, or it could be a machine where you're running these commands, and Docker host is where you want to run the containers. So you'll make a Docker file, make a build out of it, and create an image. You pull it to the registry. So the registry will gonna hold the image for you, and then you can pull the image back and run a container out of it. So container provide namespace isolation in terms of processes, managing network interface. Each container has its own networking stack that includes its own IP address and the TCP and UDP ports. Managing access to the IPC resources, all the mounts, so the storage is isolated and individual, and they have the kernel and version identifiers difference as well. That is for the basic. Any questions you might have? And feel free to join into the Google Meet as well if you want to. Let me just check if there are any questions there. Yeah, session is recorded. Essentially, it's YouTube Live, so you can always go back and view it. And that's the reason we got a lot of feedback that sessions should be recorded and how we can access the previous sessions. That's why we opted for the YouTube Live part of the session. So I'll be doing mute on everybody who is joining on the Google Meet, and let me know in the chat if you want to speak, and then you can, or if you want to share your screen when we are doing the labs, we can troubleshoot it. So if you have already done the Docker Hub registration, let's go to Docker Labs. Again, you can go to the main page, ShareLearn, go to Docker Labs. It will take you to the list of all the labs we have right now. Click on Docker Lab 101. And this lab will be just checking how the Docker environment looks like. And the good part about it is you don't have to do any installation if all the resources are pre-provided. So the step 0 in the first lab is create Docker Hub account. So as we discussed, create an account and then go to play with Docker. That's this link which we have already opened. Log in with your Docker Hub account and click on start. So let's do that. Next is it'll start a 4-hour session. Click on add new instance. So we have a new 4-hour session. Let's click on add new instance. This will give you a virtual machine, or it's a Docker and Docker concept. So it's Docker running on inside the Docker environment, but it'll give you a pre-installed Docker environment where you can run all the Docker images and the Docker commands. So click on the terminal and run this command. Give me a second. I'll just share the YouTube link with everybody who's joined on the Google Meet. Okay, so next is we're going to run Docker run hello world. Sorry, that was my YouTube link. So what this has done is this look for the hello world image in the local repo. And as we have not provided any tag, it used the latest tag for it. As it has not found it locally, it pulled the image from Docker Hub, confirm the digest. So it'll tell you what is the digest for the image to confirm that you're downloading the same image as you desire. In this case, it's a very small image, but if you're downloading your own image, it'll be a good practice to verify that. So it's just inform you that downloaded newer image for your hello world. And all this image is doing is testing the Docker environment and printing this message, hello from Docker. This message shows that your installation appears to be working correctly. To generate this message, Docker took the following steps. Docker client contacted Docker daemon. Docker daemon pulled hello world image from the Docker hub. Docker daemon created a new container from that image, which runs the executable that produces the output you are currently reading. The Docker daemon streamed that output to the Docker client, which sent it to your terminal. So this screen is coming from the Docker daemon. So then it's talking about you can do more steps in here. Now, coming back to our lab, we can see there are some bonus steps there, which is check Docker running container. You can do that with Docker PS, but you'll not find anything right now because this container has exited, so it's no more there. And for that, you can do, if you want to check the containers which have exited, which have done their job and completed, So just to repeat, the people who are joining Google Meet, primarily we have a Google Meet to have an interactive session. So if you're doing the lab with us and you have something to troubleshoot, you can share your screen, or if you have to speak, then we will go to Google Meet. Otherwise, our platform with the feedback we have received for this workshop will be YouTube. And let me just quickly check YouTube as well. We don't have any questions right now. So um, the security is better compared to the process we have in a virtual machine. So in a virtual machine, if you have two processes, there's no security in between them. So Google Meet link is in the description of the video. But essentially, there's a lot of talks and deeper discussion we can go into the security, and we can do in a follow-up in a higher level workshops. This is purely basic and try to cover the initial aspect of breaking the ice in the Docker environment. So with PS minus A, we can check all the containers, even the one which have exited. And here we can do an inspect on the container as well. So we can say Docker inspect, and as we have only one container, all we have to do is 7, and it'll give you a lot more details. Okay, so if you guys want, I can share it on the Google Meet as well. But the idea of the Google Meet essentially is if you have to share something, then we can use it. Let me see if I can share it here as well. Okay, so we should be good now. We are on the Google Meet and on the, give me a second. Okay, so with this, you have an option to either follow on. Okay, that would lead to the problem. So let's keep YouTube live for sharing and live session and for screen share, and we only use Google Meet for if when you have to talk or you have to share the screen. Here, Docker inspect essentially is giving you more detail on the container, and we'll go in further workshops. Further labs. We will be covering what all things are captured over here as well. You can also do the inspect on the image, and you'll get more familiar with the labs we do as follow on. Any questions so far? Yeah, let's wait on running the. You can do anything, but let's just hold on and cover the basics before we jump on to the. We can always do the discussion in future in the after we cover basic labs. Okay, so let's go to lab 102. In this one, we again have the steps of create a Docker Hub account if you don't have one already, and then open play with Docker and log into it. Click on start. We already have a 4-hour session with the instance, so we'll just move on to step 5. In this step, it's telling us to pull a bunch of images. So we'll understand how the pull work or how to pull an image. It, for you, it'll be a good practice to do one by one rather than doing all of them with a copy paste. So if I do that, you'll see that it's pulling an image individually. When I don't provide a tag, it'll pull the image with the latest. And if you provide the tag, the particular specific image with that version will be pulled. In this case, we're just pulling an image for Ubuntu. And this is not an essentially operating system. This is very lean version of the Ubuntu. So let's look at the images we have on this machine now. If you do Docker images, you'll see that we have Alpine latest image, Ubuntu 16.04, Ubuntu 20.10, Ubuntu latest 18.04, 3.12. And if you look at the size of these images, especially Alpine, you'll see that you'll get pretty much your OS level capabilities. So all the tools around the kernel which you use, definitely there's no kernel in these images, as every container relies for kernel requirement, it relies on the host machine where it is running. So the size of these containers or these images are really small. Especially the Hello World, it's built from the scratch. It's just in few KBs, and rest of them are a few megs. And at times, some of the images could be hidden for some reasons. You can do -A and see all the images. Now, if you want to check what all version of Ubuntu I have, you can do Docker images Ubuntu, and it'll show you what all version, what all tags you have for that image locally. It'll not show you what all possible tags it could have. Now, you can do the same thing with the ls, but this time it's the image, not images. And that's the specific reason we have this command here to make you practice that Docker images and Docker image are different commands and they have different purpose. Same thing on the Docker. Instead of doing Docker PS, you can run the Docker container. They have different capabilities, um, but essentially could serve your purpose. In this case, what we're trying to do is we'll run the container and run a command inside it, ls-l. So it got the image which it found locally, as we have already pulled those images, and it initiated a container for us, and then ran a command, and then exit the container. You can run any command of your choice. So I ran ls-l to see all the directories we have in the root folder, but we can also run echo hello alpine. So it'll do those things for you. This is just to get familiar with the Docker commands and container you can run with them. Now, this one is different. It appears that you will be running shell and it'll stay there, but that's not what happens when you run it, because shell has no wait time or sleep over there. It'll run the command and it'll be done. So let me take some questions as well. The reason we took 7 here is you when you have to identify an image, you have to pick, let's say I have 10 images over here. I have to pick something which remove the ambiguity. And as we have only one, we just did with the 7. If we have 2 images with starting with 7, I could do 7C and go there on. I mean, I could take the entire image name. Hello World does not comes with the Docker installation. You can see here, it when we ran Docker run hello world, it says unable to find image hello world locally, and it pulled the image. So there's no image which comes with Docker. It doesn't, so this, if you look at an operating system, it's a kernel, and there are a lot of tools around that. Uh, Kernel is the responsibility of the host operating system, so no image will gonna hold the kernel related binaries, and all the drivers and systemd. Even the SSHD is not required in a container because there's no way you can SSH into a container. Again, you could do that, but that's avoided. Generally, you use some other tools to access inside the container. So same thing. You can go to Docker Hub and see if there's an image already there. Otherwise, you would have to work to get that. So RHEL, so RHEL 7, I believe this is the image from the Red Hat. So if you're looking for any image, you can go to Docker Hub, search for it, and then you can run it in your environment, whether local or in this test environment. Let's go ahead with the steps here. So in this case, I want to go inside the Docker container and run some commands. And what I have to do for that is I have to do Docker container run, but I have to use the options -I and T. I is for interactive session and T is for the terminal. So I want an interactive session, and I want my input and output to be available in the terminal. That's why now I'm inside the container. And let's do a hello world echo and put it in a hello.txt. We can actually exit in this lab. We can come out of the container with exit. Now, if you do Docker container ls, you'll see that there's no container there. And with the ls -a, you will see all the containers have done their job and they're pretty much sitting in the exit state, but they still retain everything you have done inside them. So if I start the container, which we just worked on and created that hello.txt, which I believe is this one. So in this case, I have two containers starting with 5. So I have to use, if I use 5 here, it'll tell me it's ambiguous. You have to tell me more information about it. Multiple IDs found with the prefix you provided. So the container I'm looking for is F, the first one, which is 5F. So that removes the ambiguity. And it started that container for me. Now, if I do ls, it'll show me that container is running. And in order to attach to a running container, we did the initial one with the run, but if the container is already running, you have to use the exec command. You can use -it over there as well. But in this case, we just want to know that our hello.txt exists. So if I do 5f and ls, you'll see that the file which we created earlier before the container has exited, it still exists. So till the time you go and remove this container, it'll gonna persist all the information. That concludes our lab 102. So all the labs which we are discussing and we have on the lab, we have on our website, they'll also have a video with them. So you can do that at your own convenience. But the idea of the workshop is you do the lab with us so we can help you and any sort of troubleshooting you might need. Let's go to the next lab. So in this one, we'll be working more with the images. Again, you have to start, if you're picking this lab on a fresh day, you have to go with all the steps, but we are already inside the container. So we'll just go to the step 5. And this time we're just going to IT with Ubuntu Bash. So let's do that. And what we're doing is we're essentially just doing an apt-get update and installing a tool, Figlet. It could be any tool you want to install, and then running a command on it. So if I do that here, it'll do all the, it'll update the repos, install the Figlet, and run the Figlet command for us. And let's exit out of it. Now, if I do container ls minus l, ls minus a, now if you do it fresh, again, you'll see only one container here, but as we are doing the labs one after the other, we see multiple containers here. In this case, we are interested in this container. So let's check what has changed from the base image we used and whatever changes we have made in there. So if I do 3 here, that's the only container I have. So it'll show me all the changes which have been made on that base image which I used. I used Ubuntu as the base image. Then I did apt-get update and installed Figlet. And those all information is available if you do a diff on that container. Now you could do a container commit. Essentially, let's say you got a container, you got an Ubuntu image, you did a bunch of changes to it, install your application and everything, and now you want to save your work, so you can do commit. That'll create a new image. So if I do docker image ls now, you'll see that a new image has been created, which has no name or tag. So I can put a tag on it saying that docker image tag, and let's use F287 just to be remove the ambiguity on the, and name it as first image. Now if I do ls, you'll see that the name has been given to this image. This is the image which have been committed after you made the changes to the base image. So this is your first image, and as we have not provided any tag after the first image, it is considered latest. Now if you do docker image ls, you'll see, as we have seen in the previous one as well, that you have a new image with the latest. Now if I use this new image and run Figlet hello, you'll see that Figlet is already installed and all these things are already there. Now, let's say this is a host VM. This is a container and container setup, but so your container will be a process over here. So let's see if we have any container running. So we have this container running, and you'll see that that'll be running as a process on the machine. But it has its own IP address and storage isolation. As we go deeper, you'll get more understanding of how these function. You have separate networking, separate volume for every container. So it's different than the host VM. So let's say you have a virtual machine and you're running 6 containers on it. Each one of them will have its own IP address and its own storage space. That's how it differentiates from the VM. And with that, we complete the lab 103. Let's go to lab 104 and let's create a container with, create a Docker image with a Docker file. So by default, we always name a Docker file as a camel case not a camel case, essentially. It's just decapital Docker file. If you're not doing that, you have to provide the location of that file. So if I do vi docker file, so vi is just an editor you can find on the Linux machines. It's just a text editor, and you do insert to writing in it. And I'm just doing copy paste here. Same exercise which we did in the previous one. We're taking base image as Ubuntu. So we in Docker terminology, we call it from. So we'll say from Ubuntu, and then we'll say, what do you want to do after that? You're doing apt-get update, and then you're doing apt-get install figlet. Command is the step which will Docker will gonna run every time you run the container. Now this could be a process you're running, as in your web server, your own application, could be Java based. So in order to get out, I'll do escape. Yeah, it's not accepting escape. Hmm. This is weird. When I'm doing the escape, it's taking me out of the. Okay, get out of it. I did Control C to get out of it. But yeah, if I do a VI, I have my instructions over here. So this Docker file is ready. Docker files could be very complicated, so we can talk about deeper, but this is the base um, instruction just to get familiar with from, run, and command. So from is where you're starting your, what is your base image? Run is every step you're taking after that. And then command is, that is the instruction you're saying to run every time your Docker container is run. Now I want to build an image from the Docker file. So what I did is I said Docker image build -t. I'm giving a tag to it. This time I'm saying image from file :01. And I just said dot to use the Docker file from the local directory. And as you see, it divided the process into 4 steps, as we have 4 steps in our Docker file. So it took the from Ubuntu, it makes sure that image is available, and it created the, make sure that, okay, this is the image I'm using as a base. And the second image, or second layer of the image, it did the apt-get update. In the third layer, it got the figlet installed. And in the fourth one, it's just running the command. So now if I run this container, I'll just say Docker container run. I'm giving my image file and colon the tag I want to use, and it just print as desired. That's what we kept in the file. Now, if you want to check what all images are there, you'll see the new image has been added here. You can also check the image history, in the essence that what all changes have been made to this image. So if I do that for Docker image history, image from file, because I've been provided the tag and default is latest. So you will see that some changes have been made before even we got this. So these are the changes made to the image which we use as base. And then we did apt-get update, install the figlet, and have the command on it. Now, let's go to the Docker file and make some changes. Again, do the vi insert. I'll just add a small thing to it, 0.2. Again, it just let me exit out. So I do Control C, WQ to save it. Now I create a new image with the tag 0.2, and I give the dot as my Docker file is located in the same folder and it is in the proper naming structure. It reuses the image which it has created earlier, and the only change it does is when the things have changed. So it doesn't redo the entire process again, as all these images which it created are already retained. So if I do docker image ls minus a, you'll see that these are the extra images which were created just to create my image. The 4 steps, 4 layers are actually separate images. They're retained so that if a change is made, they're reused and only process where the changes are made will be affected. So in this case, it used the cache as it says here. So it didn't redid the installation or apt-get update. Understand that it is a very simple process over here, but if you have like 50 steps in your Docker file, which is not advisable, but let's say you have like 10 or 5 or some steps in there, significant steps, you don't have to do them again and again. Docker will gonna do only thing which you made the changes on. So in this case, we made the changes on this step, wherein we changed hello Docker to hello Docker 0.2, and it says, okay, I just use these images from the cache and I create new image for this one. Now we have the 0.2 as well. If we run 0.2, we're going to see this message has changed and it is 0.2 right now. So if we do 0.1, we'll see hello Docker, and then the new image or whatever changes we have done will be captured. So as for the agenda, I guess we have 2 more minutes for the labs. It's totally up to you guys. How do you want to proceed? We can get on to, if you want to ask a question, feel free to put it in the chat, comments, or get on to the Google Meet and we can talk free questions, whatever you want to ask. We can go on that, either related to these labs um, or any other thing related to the Docker. And I think we'll have limited time to be able to cover the Lab 105. We have a few folks on the Google Meet already. Do you guys have any question? So again, I can cover quickly the labs and what we have on the website. If you go to Docker Labs, you'll have these, all of them, and you can get a Docker playground from Docker, Play with Docker. Similarly, if you go to the home again, you'll see there are Kubernetes labs, which we cover Kubernetes in tomorrow workshop. So if you haven't joined already, feel free to go to our homepage, ShareLearn, and you'll see free Kubernetes workshop. You can join in there. Similar setup, it'll be Google Meet with YouTube Live. As that's what the feedback we have got so far. So if you have a different feedback for us, please feel free to help us. And we also have Linux lab section, and Linux is also covered heavily on our YouTube channel. So we have videos on Bash. They are very basic, but they cleared a lot of concepts. Hey, sure, yeah. I'm sorry, I think we have that echo problem with the YouTube live parallelly going as your voice is going back. So can you mute the YouTube and then repeat the question? Not the Google Meet, mute the YouTube live. Yeah, hey, okay. So you're talking about play with Docker, right? If you could mute this, I'll show you, and you go back to the YouTube screen. You'll see that I just did the same command which you were talking about, and there's this link which has come up. So in order to check that, I have to do this, although it's not working. Hmm. Because I guess you're doing the RM, the container might have exited. Your container is up. Yeah, so ideally you get access to the container via this, but it looks like it's not working. Yeah, it looks like it's an issue with the play with Docker that it's not giving the desired result in the port redirection. And the lab being free, that's kind of a con of using it, that there are some limitations or bugs which we have to live with. Any other questions? Any feedback? Any questions? So yeah, I mean, feel free to give us the feedback on our emails. We do have, we're working on improving our website, but for now, you can find a Facebook group over here, a LinkedIn group, a Slack channel, a Telegram channel, and of course, information about our YouTube channel. Please subscribe it, and yeah, like this video, as essentially what like does is tells the YouTube that you would like to see similar videos, and you promote this video as well. We also have some sections about the books which are made available by different vendors free of cost. So feel free to look at them. We are working on populating more, but you can see the conference informations over here. So events. We have the practice section here, and we're working on more to populate the certify section. which we'll be putting more and more information. So we're one of our scope is to put and everything included in the certified Kubernetes admin and application developer and certified Kubernetes security exam and have lab associated with it. So if you go today, we already have two labs which are very specific to the exam level. And we have 100 series, which will be basic, which we have already have few of them. The 200 will be intermediate, 300 will be the certification related, and 400 will be the production specific. But we are going slow, and essentially this might be our last session of the workshop on the basic level. So we're gonna go more advanced from here, and that's the reason we have it on YouTube Live as it's recorded. It could be captured by anyone if they want, and they can catch up for the next lab. So go to ShareLearn. It's shrlrn.com. You can see that link in our description as well. And you'll find all the information, the lab, um, and all the information there. I can also put that in the YouTube chat. So we're working on the bootcamp part of it and still evaluating, considering there are already so many good trainings. What do we want to do? Uh, we welcome feedback, so tell us what do you feel about it. It'll be more intense and more we feel that it should be in the involvement rather than just capturing the information. So we're looking into it still. We haven't made up our mind or made a program to get into the certification training. So if anybody else is also interested, this is the link for tomorrow's workshop. And this is the video for it. So it's again a YouTube live, similar to the session. So today's video is over here, and tomorrow's video is over here. One more thing, at a rare situation, you might see that play with Docker or play with Kubernetes will be out of resources. It happens sometimes. Just refresh it, close the session, or if it even then if it doesn't work, come after a few minutes or maybe an hour. Understand it's a free resource, so not much could be done to maintain the capacity on it. But it's a very good resource. You can get up to 5 instances here, and essentially it didn't work in the scenario which we were trying to, but it works in most of the situation. Let me actually see if it is the issue which I'm thinking it is. So as we are here, if you want to get rid of a container, pick the container ID. Docker rm minus f is just for the force, as it would require you to stop it otherwise. So if I do this, yeah, so the problem was you put, what you did is you put this as the host and this as the Nginx. Essentially, that's just the way you have put the first and second. That was the problem. So it will run if you do 8080. And if you like do want to do 80, sorry, if you want to do the one you were trying to do, let's do docker rm minus rf. And if I do, so you want host to have 8080, container is exposing a fixed port, so you cannot change that. So you're going to have that working. The idea is inside the container, in the Docker file, a specific port has been exposed. So you cannot change the second port. That is the container port. You can only change the first port, which is for the host. Do you still have a question on that, or that clarifies your question? Yeah, normally we do a very interactive session on Google Meet only, but the reason everybody has been asking for recording and replay, as a lot of people are not able to join on exact time, some people are not available during that time. That's the reason we opted for the YouTube Live, which records the session and give everybody an opportunity to be able to replay if they join in the mid-session. Please feel free to share feedback to us if you like it the other way. Um, Also, for a limited time, we have a Let's Talk option over here. So you can click and book a 15-minute session with us. Um, it'll be approved as per the availability from one of us, and we can have a one-to-one session on a quick topic. When you're booking it, please make sure you specify what you want to discuss, or you're going to get a reply from us asking that detail. And that's completely free. It's for us to understand your requirement and get feedback. So far in Kubernetes labs, which we'll be covering tomorrow, we have a similar setup, and we have 6 labs on 100 series and 2 lab and 300 series. So 2 labs related to the certification and 6 labs related to the basic of Kubernetes. We're working on a lot more labs and Python, Azure, Docker, and Kubernetes. So bookmark to this, join our channel of communication, and as we're working to improve our site as well, we'll be adding more and more information over there. We are dot on time. Even if you want to have a like a one-to-one question and don't want to be it to be a part of YouTube Live, as I can understand, sometimes you don't want to make it public. Just stay on the Google Meet or join the Google Meet if you have not already. I'll stop the YouTube Live in another minute, top of the hour at 8 over here, and then we can have a discussion on Google Meet. With that, thank you for your time, guys. Again, the website is ShareLearn, shrlrn.com. Looking forward to see you in upcoming workshops as well. And share the feedback, help us improve how we can help you and improve the entire community. Thank you for your time again, guys.